Why is perfect energy conversion impossible? Imagine trying to turn every bit of heat into useful work without losing anything along the way. It sounds ideal, but in reality, it just can't happen. That's because of a fundamental rule called the second law of thermodynamics. This law explains how energy transformations always involve some loss, usually as waste heat. When energy changes form, like from heat to mechanical motion, not all of it remains available to do work. Some of it disperses or spreads out, making it less useful. This spreading out of energy is measured by something called entropy, which increases whenever energy is transformed. As entropy goes up, more energy becomes unavailable for work. Think of it like a messy room. Once energy has dispersed, it's harder to gather it all back into a useful form. The second law also states that you can't build a machine that takes heat from a single source and turns it into work without any other effect. This means no engine can be perfectly efficient. Even the best engines, like the Carnot engine, which is a theoretical model, always reject some heat to a cooler reservoir. This waste heat is unavoidable because natural processes tend to move toward equilibrium or balance. In real life, this means all engines, refrigerators, and energy devices operate below perfect efficiency. For example, a car engine converts fuel into motion but loses a lot of energy as heat. Power plants and refrigerators face the same limits, with some energy always escaping. So, the reason perfect energy conversion is impossible is because the second law of thermodynamics requires that entropy must increase or stay the same in any process. This increase in entropy means some energy always becomes unavailable to do work, usually as waste heat. No cycle can convert all heat into useful work without other effects happening. This natural limit guides how we design energy systems and helps us understand why we can never reach 100% efficiency.